Imagine an ocean vast and unexplored, patrolled not by human sailors but by silent, crewless machines. These aren't just simple robots, they are complex systems imbued with artificial intelligence, designed to navigate and operate independently. Beneath the waves, a new kind of hunter glides, a sleek, autonomous vessel guided by sophisticated artificial intelligence. It moves with a purpose, a silent guardian of the deep. No captain barking orders, no crew manning stations, just circuits and lines of code, a symphony of algorithms orchestrating its every move. Its mission to patrol the vast expanse of the Pacific, a silent sentinel watching over the watery realm, listening intently for threats, subtle anomalies and dangers that no human ear or eye could ever detect. It's a constant vigil, an unwavering commitment to security. This isn't science fiction lifted from the pages of a novel. It's the dawn of a new era, a fundamental shift in naval warfare, reshaping the balance of power on the world's oceans. For centuries, navies have relied on the courage and skill of ships and their sailors, a legacy forged in battles across the globe. Now, silicon and cold, hard steel are quietly taking the helm, ushering in an age of autonomous naval power. These machines don't tire under pressure, they don't succumb to fear in the face of danger, and they never waver from their mission. They process vast amounts of information at superhuman speeds, analyzing data streams and identifying patterns invisible to the human eye. The implications of this technological leap are immense. Strategy, international ethics, and the very foundations of global power are all being fundamentally reshaped by this new reality. What happens when the critical decision to fire a weapon is made not by a human being, but by a complex algorithm? These autonomous systems are specifically designed to operate in the most challenging environments where reliable communication with human command is simply impossible. They may be forced to make life or death decisions entirely alone, operating far from any human oversight or intervention. We're crossing a critical threshold, one that will irrevocably change the world's oceans forever, altering the very nature of naval power. Like the advent of the dreadnought or the introduction of the aircraft carrier, AI-powered warships will inevitably render older fleets obsolete, relics of a bygone era. The future of naval power belongs not to the largest, most heavily armed ship, but to the smartest, most adaptable swarm of intelligent machines. Future naval battles will be complex contests of algorithms, data analysis, and cyber warfare, fought as much in the intangible digital realm as they are on the physical waves of the ocean. The unfolding story of this new ocean is only just beginning to be written, and its chapters will undoubtedly be filled with both incredible promise and unforeseen peril. The silent hunters are coming, emerging from the depths to reshape the world as we know it. The world's oceans, the lifeblood of our planet, will never, ever be the same again. The age of the intelligent machine at sea has officially arrived, heralding a new chapter in maritime history. And we are only standing at the very beginning of this profound transformation, witnessing the dawn of a new era. The shift from manned to unmanned vessels represents a monumental change. It's a paradigm shift, altering the very essence of naval power and strategy. Is the biggest change in naval history since sail gave way to steam. This transition marks not just an evolution, but a revolution in how we approach maritime operations. Ships were once floating communities defined by the people aboard, their skills, their camaraderie, and their shared experiences at sea. Now, technology is rewriting the rules, dictating new strategies, and redefining the very nature of naval warfare. New vessels are platforms for sensors and weapons designed to gather intelligence and project force with unparalleled precision, run by sophisticated software, algorithms, and artificial intelligence, enabling autonomous operation and decision-making. Modern warfare is too dangerous for large, crewed ships, which present a concentrated target in an era of increasingly sophisticated weaponry. One missile can mean disaster, potentially crippling a vessel and endangering the lives of hundreds or even thousands of sailors. Unmanned ships can take risks, venturing into contested waters and undertaking missions deemed too perilous for manned vessels. Go where humans can't, operating in environments too hazardous or remote for traditional naval deployments. And if lost, only equipment is at stake, mitigating the human cost of naval operations. Without the need for food, sleep, or living quarters, these vessels can be designed with a singular focus on mission performance. Autonomous vessels are smaller, faster, and more agile than their manned counterparts, and can stay at sea for months or even years without the need for resupply or crew rotation. This enables a global presence impossible for traditional fleets, extending naval reach and influence across the world's oceans. The change isn't just swapping sailors for robots, it's a fundamental shift in naval doctrine and operational concepts. It's rethinking the fleet itself, from its composition to its deployment strategies. Navies are moving from a few big ships, each representing a significant investment and a potential single point of failure, to many small, specialized unmanned systems, creating a more distributed and resilient naval force. Some scout, providing real-time intelligence and situational awareness. Some carry weapons ready to engage targets with precision and speed. Others relay communications, ensuring seamless connectivity and coordination across the fleet. This networked approach is resilient, creating a dynamic and adaptable naval force. Losing one unit doesn't cripple the force, as the remaining systems can seamlessly adapt and continue the mission. It's a shift from brute strength, where size and firepower were the primary determinants of naval power, to intelligent, distributed power, where agility, adaptability, and information dominance are key. The age of silicon sailors has begun, ushering in a new era of naval warfare. The future fleet is already taking shape, poised to revolutionize maritime security and power projection. The future of AI warships is already here. The US Navy's Sea Hunter, an unmanned trimaran, patrols for submarines autonomously for months. It's a warship with no bridge, no bunks, just sensors and code. Underwater, robotic submarines like Boeing's Echo Voyager operate for months, gathering intelligence or laying mines. These drones can launch from a pier, complete missions alone, and return undetected. The real power comes when these platforms work together. Surface, underwater, and aerial drones sharing data in real time. This creates a network that can overwhelm opponents with coordinated attacks. Other nations are racing to catch up. Britain tests autonomous mine hunters. China builds its own unmanned fleets. These are not prototypes. They are the first generation of a new doctrine. The autonomous fleet is here, and it's learning fast. The relentless drive towards autonomous warships isn't just a matter of technological advancement. It's fundamentally fueled by cost considerations. It's also about strategic advantage and, ultimately, survival in an increasingly complex and dangerous world. Navies are constantly seeking ways to optimize their resources and enhance their capabilities. Modern warships are staggeringly expensive, representing a massive investment of national resources. The price tag for a single advanced vessel can easily reach into the billions. These complex machines also require thousands of highly trained sailors to operate and maintain them, adding significantly to personnel costs. Unmanned systems offer a compelling alternative, often proving to be significantly cheaper to procure and operate. These autonomous platforms can perform many of the same missions as their manned counterparts, from surveillance and reconnaissance to mine, countermeasures, and anti-submarine warfare. Swarms of robotic boats, working in coordinated fashion, can pose a significant threat to even the most advanced and heavily defended ships, overwhelming their defenses with sheer numbers. This capability is particularly significant, leveling the playing field and providing smaller navies with the means to challenge larger, more powerful adversaries. Beyond cost and capability, AI brings a crucial edge: speed of decision-making. The advent of hypersonic missiles means that humans have only seconds to react to incoming threats. AI, on the other hand, can process information and respond in milliseconds, a critical advantage in high-speed combat scenarios. In this rapidly evolving environment, faster decision-making is not just an advantage, it's often the key to survival. Persistence, the ability to maintain a constant presence, is another significant advantage offered by autonomous systems. Autonomous vessels can stay on station for months at a time, far exceeding the endurance capabilities of manned ships. This allows for continuous monitoring and intelligence gathering, providing a persistent awareness of the maritime environment. They can also be used to enforce blockades, effectively controlling strategic sea lanes and denying access to adversaries. This constant presence serves as a powerful tool of influence, projecting power and deterring potential aggression. The machine's inherent endurance Its ability to operate tirelessly for extended periods and its speed, its capacity to react and maneuver with unparalleled agility, are fundamentally changing the established rules of naval power, creating new opportunities and challenges for nations around the globe. Navies that embrace these advancements and adapt to this new reality will be best positioned to dominate the seas in the years to come. The age of the persistent, intelligent machine is undeniably here, transforming naval warfare as we know it. The oceans are being watched and monitored as never before, ushering in a new era of maritime awareness and security. The revolution isn't just unmanned ships, it's the intelligence that drives them. AI warships use advanced sensors, cameras, radar, sonar to build a real-time picture of their surroundings. They identify threats, analyze behavior, and track hundreds of targets at once. AI turns raw data into actionable intelligence, classifying and prioritizing threats. Swarm tactics are the game changer. Multiple vessels coordinate like a single organism, sharing data and adapting instantly. If one is lost, the rest adjust automatically. Swarms can overwhelm defenses, search vast areas, or deceive enemies with coordinated maneuvers. AI controls every move, achieving tactical coordination impossible for humans. This is not just automation, it's emergent, intelligent behavior at sea. The digital mind fights as a unified force. The future of naval combat is a contest of algorithms. As machines gain autonomy, we face a profound ethical dilemma. Lethal autonomous weapons, should a machine decide when to kill? Most systems keep a human in the loop, but what if communication fails or speed is critical? Some argue AI could be more ethical, unemotional, precise, following rules. But can an algorithm truly understand the laws of war, or distinguish civilians from combatants? Who is accountable when a machine makes a mistake? Many call for a ban on fully autonomous weapons, insisting life and death decisions remain human. The question of control haunts the rise of AI warfare. Autonomous warships don't end the need for sailors, they transform it. The new captain is a fleet orchestrator, commanding swarms from a data-filled control room. Tomorrow's officers must master AI, data science, and networked warfare. Their job-set strategy, define rules and oversee missions, intervening when human judgment is needed. Humans and AI become partners. Machines handle data and speed, humans provide ethics and intuition. Training is evolving, simulators and courses on robotics, cyber and AI ethics are now essential. The sailor's role shifts from physical to cognitive. Their hands may leave the wheel, but their minds are more vital than ever. The human element remains at the heart of command. In the robotic age, leadership is redefined. AI is changing not just how ships think, but how they're built. Traditional warships are slow to build and hard to upgrade. The future is modular. Ships as platforms with swappable mission modules. A vessel can switch from anti-submarine to electronic warfare in days. This flexibility lets fleets adapt quickly to new threats. Ghost fleets, unmanned flotillas, augment main forces designed for speed, stealth, or specialized roles. Distributed, layered fleets are harder to defeat than a few high-value targets. The ultimate vision, a dynamic, networked ecosystem of crewed and unmanned ships, reconfiguring on the fly. Fleet design becomes as important as ship design. The blueprint is for a living, evolving naval system. Adaptability is the new edge at sea. The promise of AI navies has sparked a global arms race. The US, China, and Russia are all in seeking dominance at sea. The US bets on AI to offset China's growing fleet, projecting power across the Pacific. China aims to leapfrog the West, building swarms of unmanned vessels for regional supremacy. This rivalry brings new risks. Cyber attacks could hijack or cripple autonomous fleets. A line of code could be as deadly as a torpedo. Machine speed warfare leaves little time for human judgment. A glitch or misread signal could trigger conflict before anyone can intervene. The speed of AI may outpace human wisdom. The future of naval power and global security hangs in the balance.